Critical for all new fighters to avoid being seen by enemy radar.
Non-stealthy aircraft just will not survive in the air battles of tomorrow.
Stealth technology was created to counter advances in radar. Radar works by sending out radio waves and measuring the amount reflected back to determine the distance, speed, and course of an object. But stealth aircraft are designed with surfaces that deflect radio waves away, making them nearly invisible to radar. The world's first stealth production aircraft was the F-117 Nighthawk.
The reason that airplane is faceted is a limitation of the computer technology at the time. It's easier to model a finite number of flat surfaces than it is a bunch of curved surfaces.
And while the aircraft was a breakthrough at the time, the facets limited the plane aerodynamically. But now, thanks to more powerful computers, engineers can design aircraft that do not have to sacrifice aerodynamics for stealth.
The F/A-22 aerodynamic slickness allows it to have the lowest drag of almost any aircraft ever produced.
The F-22's aerodynamic superiority, combined with its stealth and firepower, make it a far better adversary than any aircraft before it. The F-15, which the F-22 will replace, has been a very successful fighter, but it is not stealthy. The F-117, while stealthy, carries no air-to-air weapons and is not designed for air combat. It relies on stealth and mission planning to protect itself. But the F-22, on the other hand, is not only stealthy, but comes with a full complement of air-to-air and air-to-ground weapons.
The primary armament is in weapons bays underneath the airplane, where we carry 6 medium-range radar-guided missiles.
By carrying the weapons internally, it preserves the stealthy shape of the plane. For closer infighting, the F-22 has short-range missiles and guns.
Behind these two doors right here is the side weapons bay. This is where we carry a heat-seeking missile. For close-in armament, the Raptor's equipped with the M61A2 cannon. The muzzle is hidden right behind this door right here. It's hidden because of the stealth characteristics of the airplane. Cannon carries 480 rounds and is capable of shooting 100 rounds a second.
The F-22's advanced weapons systems will make it a formidable interceptor, as will its unique ability to find enemy aircraft without revealing its own position. When other planes use their radar, they become visible to every other radar system in the area. But that's not the case with the F-22.
Perhaps the highest tech part of the airplane is the radome itself. Not only does the radome have to be stealthy, but it has to be able to transmit and receive its own radar signals.
How the F-22 radar achieves that remarkable feat is classified. But what is known is that the F-22 can see enemy aircraft at a distance while remaining invisible to them.
The first time that the bad guys will really know there's an F-22 in the area is when one of them blows up.
Along with its advanced radar system, F-22 is the first fighter to have Super Cruise, the ability to travel faster than the speed of sound without using its afterburners. A jet's afterburners boost speed by pouring fuel directly into the hot blast of the engines, adding fiery extra thrust. But afterburners are also wasteful, consuming enormous amounts of fuel, dramatically affecting the range and duration of a plane's mission. But the F-22 doesn't have that problem. Without using afterburners, it can supercruise at an incredible 1.5 times the speed of sound, over 1,000 miles per hour.
This is all about our pilots being able to go fast, minimize the amount of time they are exposed to any threat, do the mission that we've sent them to do, turn around and come home safely.
The F-22 is presently the only fighter in the world with supercruise, but it wouldn't be possible without a very unique set of engines.
The goals for Pratt & Whitney were to provide a
transformational engine that the Air Force needed, one that was stealthy, maintainable, and fast.
The F-119 PW-100 was developed by Pratt & Whitney after years of research. It sets the new standard for jet engines. Along with its incredible supersonic ability, the F-119 incorporates thrust vectoring.
Here we are at the rear end of an F-A-22 Raptor. First thing you'll notice are the nozzles for the F-119 engines. In flight, during a maneuvering dogfight, they actually move up and down and vector the thrust of the engine to provide maneuverability.
It helps us turn inside any foe, maneuver at low or high speeds to outmaneuver another airplane or potentially an enemy weapon that's headed towards us.
The F-22's stealth, supercruise, and vector thrusting are impressive breakthroughs, but its most outstanding feature may be its ability to nearly fly itself through advanced computerized controls.
It relieves the pilot of all the duties, gives the pilot total freedom to just look out engaged in the combat scenario.
In addition to monitoring its own performance, the F-22 constantly gathers data on other aircraft in the combat area and presents the most important information to the pilot.
We're going to have information passed to us from either unmanned vehicles or from off-board sensors so that we can integrate data and use that information for targeting. And it's the way that we are driving our forces in warfare. We are much more integrated with both other services and with other platforms, and the F-22 fits right into that concept.
The F-22 Raptor's total package of avionics, stealth, supercruise, and thrust vectoring make it the most technologically advanced fighter today.
I've never been in an airplane that accelerates as fast, that's as agile, the ability to turn very sharply, and just brings a great combination of the speed, the stealth, and the avionics to the fight that nobody else is going to be able to touch.